Thank you for joining this session with me, James from Matador Software, and we're looking at data modeling in the real world. So, a bit about me. I'm a business intelligence developer based in Scotland within the United Kingdom. I work with technologies such as Power BI, SQL, Azure Data Factory, Power Automate, a bit of Python, and more. You can follow me on YouTube, where I create videos 2 to 3 times a week, and also here on LinkedIn, where I tend to just post sort of data career advice and information about some of the latest technology. So I will dive out shortly from the camera and take you through the session, but I hope you enjoy it. And I hope you not only get a bit of perspective as to the technical elements of data modeling, shaping it in Power Query, but also a lot of the business processes that go on behind the scenes, and as a data professional, what you should be aware of and trying to achieve.
Okay, so let's look at what we're going to cover in this session, data modeling in the real world. And there's a few different ways that we're going to sort of attack this topic, so let's have a look. Naturally, when we start, we'll look at data modeling in Power BI, just an overview. So what that actually means if you've yet to sort of work with this, and some of the key data models, schemas, and again, what they mean and how you can use those. From there, we'll look into some core data modeling concepts. So things like the Kimble Methodology, the father of dimensional data modeling, and the star schema, which is the most effective way to model your data in Power BI. From there, I want to look at Roche's maxim of data transformation. I'm going to tie that in with how you really want to shape your data business infrastructure if you really want to do things in the most efficient and collaborative manner. From there, we'll actually look at Power Query and how we shape our data. So I think with data modeling, there's often a misconception that you don't really have to do anything. Well, there's a lot of steps that you may need to take to get your data in the right granularity and the right shape. So we need to prepare it. So we're going to look at a few different techniques I would regularly use in order to get things ready to be modeled correctly. So I would want to remove redundant data and checking data types. We'll look at that. Using certain functions to extract numbers from text. Again, we want to get our data into the right shape. We want to reduce redundancy and keep things as lean and performant as possible. So that'll be helpful. Go in and build a date table in Power Query. So we'll look at why we're doing this in Power Query to give you more, again, another sort of real world use case and why this would be helpful. And then we're going to create a summary table in Power Query where we can change the granularity structure and again, lean out some of the data that we're using to make things a bit more efficient and effective. From there, I want to look at some sort of real world data modeling business cases. So killing data quality issues at source, why you should do that. I've got a little sort of a flow and we can look at that. And then slowly changing dimensions, a hugely important topic when we want to look at things like referential integrity and change over time. So hope to get through quite a lot here, as well as some Power Query demonstrations. So yes, sit tight and we'll go through this. So if you hadn't modeled data before, I guess your first question may be, instead of modeling data, breaking it up into facts and dimensions, why don't I just import a giant flat file? Well, it's not efficient, first of all, but data modeling really serves a greater purpose than that. What we're doing here is we're actually giving a visual representation of key business processes. We're doing things like improving performance. A lot of these foundations are born in database management systems and languages like SQL, where we can really guarantee the quality of our data with things like foreign and primary keys. So start to think of these things as we go through data modeling in Power BI. And then naturally, we then want to sort of join our data together and build relationships. So there's a lot to it, but it is very logical and we can sort of model business concepts. It's very helpful in that language between data and the business. Okay, so this image and description is actually taken from the Microsoft documentation on star schemas. Actually quite helpful in this case to visualize a fact table and your dimension tables that are plotted around the fact table in the shape of a star, hence the name star schema. Now, it is worth noting when you're implementing these in the real world, they may have a few extra points. You may have multiple fact tables connecting to each other. That's okay. It's not an exact science. It's just a guideline in order to give you the best sort of breakdown between dimensions and facts, which is what we're going to look into. So, like I said before, data modeling is just the process of creating visual representations of those connections between data structures. And in Power BI, it really is most performant to have a star schema. You may hear this phrased as a dimensional model, essentially the same thing. And what this gives us is information about individual attributes contained within data structures. So, like I said, we're going to hear about star schemas. We'll use this language, but it's very widely adopted. It's also known as a friendly schema. It's easy to understand. It's very readable. And really, if you were implementing something like self-service BI, this is going to be understandable to the general user. Of course, within the data or the business intelligence department, there's going to be steps that we'll take that we'll look into, things like shaping our data in Power Query or steps that may come before further upstream. But here we've got two benefits listed with regards to a star schema. So usability, like I said, it makes it cleaner and organized. And there's also the performance element. So scalability is a huge bonus. And also you see the dimensions around this fact table. So the fact tables sort of are more transactional data. We can see foreign keys referenced there, which are just the primary keys from each of those dimensions so that we can connect things effectively. And you'll see the dimensions, and dimensions typically can be things that are a bit slower changing. We might use these to slice data, so it could be things like employees, products, locations, territories, and really sales and orders and things may be your traditional fact table. So by doing this and breaking things out into dimensions where previously we spoke about fact or large flat files, we can actually start to remove redundant data, and that helps us maximize storage and make things faster and more performant. It's also worth noting that your dimension tables usually reference the business context. So that might be the who, the what, and the why. So hopefully that starts to make sense, because facts and dimensions at first can be a little bit confusing. And we're going to go into some more advanced topics. So yeah, hopefully we keep everyone aboard with that train of thought. So I just want to spend a bit of time talking about those schemas that we referred to. But it's worth noting that we really would aim for a star schema or a dimensional model in Power BI just because it's the most performant. But I did want to look over our schemas and just go over what some of the common terminology you may hear means. So like we said, a star schema, we've looked at this, the shape of it in the previous slide. It consists of fact tables and dimension tables, where the fact tables are centralized and they link to these multiple dimensions. And we're going to look at this, so I won't worry too much. But fact tables tend to store, in layman's terms, the fast-moving numeric data that will contribute to key business metrics. So, that may be things like sales or orders. Now, within the fact tables as well, it's quite easy to identify because you should see the foreign keys for each dimension present here. And if you're not familiar with SQL terminology, a foreign key we can think of it as the primary key from a dimension would then go to the fact table so that we can connect it. So things like employee key would be in the, maybe our fact table or sales orders table. And the same with location, there might be a key, because then we can branch out and build those relationships. So we have facts, that's fine. And then, like we said before, dimensions would provide the context surrounding business metrics. So slower moving data that you can filter by, such as maybe locations, customers, products, branches, whatever that may be. And yeah, that's not as fast. That would change at a slower pace. And we will look at some concepts around that later. You could also think of dimensions. You may have heard them phrased as lookup tables, or that's how we may slice or filter our data to view different insights when we're actually in the sort of reporting side of Power BI. Now, you may have heard of Snowflake schemas. We wouldn't traditionally aim for Snowflake schemas, but as this session is called Data Modeling in the Real World, we have to accept that sometimes that's the hand we're dealt. And at that point in time that we're at, before we can maybe implement some improvements, that's what we need to work with. So it's important to know what they are. So they refer to data models where there's more of a hierarchical element. So maybe where you have star schemas that have started to branch off. Maybe you can't get your data down to the correct grain or normalize it to the correct level of the star schema. So then you almost have to move through different dimensions to get to the data you want. So it becomes a lot more complex to follow, maybe harder to build relationships. We may have more issues with cardinality, so we need to be careful here. And where possible, we want to get into shape where we've got the same level of grain or granularity across the board. So we will look at data shaping in Power Query and look at things like how you may want to adjust grain or shape. Now, the last one's almost a bit of a joke. It's a bit colloquial, but there's a serious element to it, a spiderweb schema. So basically, I would just call that anything that's out of control. Avoid it at all costs. Not only is it hard to read, but most likely it's actually going to give you wrong results when you go to visualize your data. So where the number one sin of data analysis would be to provide wrong or incorrect figures, well, that's a fast track to getting you there. So yeah, we will aim for star schemas and preparing our data correctly and as far upstream as possible. Before we hop into Power Query, we've got some interesting conceptual ideas. So we want to look at the Kimble methodology for dimensional data modeling. Spoke about Kimball before, the forefather of the star schema, and Roche's maxim of data transformation. Then I want to go into a little sort of whiteboard flow illustration I have prepared just to show how this actually relates, say if you were in a data department in the workplace, and make some of those concepts come to life. Roche's maxim is very interesting, so good to look at that. Now, you may have read the Data Warehouse Toolkit. If you're a bit newer to this concept, maybe you haven't, but it's sort of the Bible on a lot of these concepts like star schema and dimensional modeling. So although the subject does seem quite complex, the concept is quite simple. Now, the star schema has been on the go for a while, introduced in 1996. So it's important to note that these concepts aren't new to Power BI. These are time-tested, there's documentation there, foundations and things like SQL. There's plenty documentation and reference. Now, initially designed to be used when building data warehouses, still would be used as a guide in staging areas, SQL environments, even if people are using Power Query as some form of data warehouse. It's still hugely relevant and doesn't look like it won't be anytime soon, and it allows for a broad business understanding, so that's important. And also, like we said, that query performance, the growth and scalability and speed of data, speed and understanding data processes. So as defined by Ralph Kimball, there's a 4-step dimensional design process that we really want to follow. We need to model this based on our own business processes that we're looking to tackle. If you're not part of a business and you're learning this, of course, there can be use cases. You can get databases, for example, the Northwind sample database and GitHub, and then you can find ER entity relationship documentation that can explain some of that for you. You then want to find a granularity, so a level of detail, and that needs to be standard across the range of data if we really want to model effectively with a star schema. And then we need the dimensions and the facts. Again, this needs to mirror a business process, so we need to look into that and really understand the environment we're working in. So Roche's maxim of data transformation is very helpful. Maybe you already do this out of common sense or inherently, but to go over this, it states that data should be transformed as far upstream as possible and as far downstream as necessary. So where upstream refers to where the data is originally produced, and downstream refers to where the data is eventually consumed. So you could assume that upstream in this diagram I've prepared would be the source app, and downstream would be sort of where the end user consumes those ad hoc data requests, Power BI reports, whatever. Now, I say source app because in the data world, that's really a common use case. What would maybe happen, you may work in the data department in a retail store, and naturally you have something to track, products, your sales, so that you can build insights on this. Equally, that might be sourced within a web app. You have a SQL database in the background, pulling the information that's through a web interface. You might work for a healthcare company that dishes out an app to its customers, and again, the same process kind of follows suit there. So you could say, looking at Roche's maxim, well, yeah, we want to do our transformations in Power Query rather than DAX, and that would be a valid point. But sometimes I think we have to think even further ahead. So we're not going to get away from the point that we have to use DAX and Power Query. That will just have to happen. You could say in an ideal world, we will do everything in a staging area in SQL. We will have a very clean source. So within that app, we've got a development team who's had our input from the data side, and we've said, hey, this is what you need to accept. This is what you need to hard code. But, really, if you come in to do a job in a data department, it's not going to be that simple because you're going in to fix issues and you're the expert and you need to manage expectations. So like I've got the X here to differentiate between the source app and SQL. We would sit just after where that X is to the right. Before that, we would assume is IT and software developers. And then this question mark here, really, because we could have just, very straightforward, great data goes into SQL, into a staging area where it's refined a little bit more. We implement those constraints, those keys. We know that as soon as we pull everything into Power BI, it's going to connect fine. Do some transformations, and we've got this nice data set where we can also give people their ad hoc data requests. Goes to the end user, perfect. Now, the reason I've got route 1 and route 2, often what you'll find is, especially if you have a bit more of a mature data environment professionally, you might have sort of route 1 where people want requests, route 2 where you're developing more specialist Power BI reports and so on. So, but we could get to a point where we're efficient, we've got views in SQL and things like that, and we can just dish out information very efficiently. But we live in the real world, and that isn't often the case. So I've got a question mark here. We could have information from, SharePoint lists, from Excels, from CSV exports, from SAP or Maximo databases. So it becomes a bit more fragmented there. So this is where Roche's maxim comes in. So really, with what we've got available, naturally, if we want to shape our data ready for data modeling, and our data sources are quite fragmented, there's not a lot we can do. We don't have much control over that source system. Well, for now, we might have to do things in Power Query. And that's the viewpoint we're taking today and what we're going to look at in the demonstrations. But it's very helpful to know because, to take another example, if you go into a company that's just adopting Power BI, they might have a history of, database administrators who who are very comfortable with SQL. So naturally, you'd want to do a lot of the heavy lifting there. You know, renaming things, you could start to group data, you could start to aggregate it. You can basically do most things there. So it's important to note, if you want to really work efficiently, that may be your best option. In other cases, Power Query might be, in other cases, DAX. It's really dependent on the business circumstances, but it's a really good thing to bear in mind. Now we're going to hop into Power Query, and like we said, we're going to take this as upstream as we can. Let's say for this example, we've got some SAP exports from, an enterprise resource planning system, an ERP, and Power Query is the highest step up the chain that we can perform these transformations. So the first thing we'll do, take it from basics, removing redundant data, checking data types, why that's important. Then we'll use some functions to extract numbers from text, then build a date table in Power Query, and then create a summary table, again in Power Query, changing the granularity and structure, taking in some of the lessons from before, and actually looking at how we might do this in Power Query. But before we do that, I just want to demonstrate our current data situation versus where we want to be after some of the transformations. So we have our orders fact table, employees, region, we've got our dimensions all there, we've got branches, customers, they're fine, they're connected well. But because we took quite a fragmented exports, let's say from our ERP, we don't have a date dimension table. Now in an ideal world, we could have set this up beforehand in SQL, but we can't do that. So we're going to need to use Power Query for this. To generate a relevant and dynamic date table that isn't hard-coded, that's also performant. So we can do that, and we'll be able to get to a full star schema of data that we can analyze in a performant and effective way. So that's what we're going to be focusing on now. So we have a fairly simple amount of data for demonstration. We have our fact table, which is our orders, and we have branches, customers, employees, regions, and we're going to look into a date table and building this summary table. Now, the first thing we would do, like if something broke, if you have anything electrical that breaks, you're likely going to check the connections, give everything a bit of a wiggle, check the fuses. Now, the first thing we would do is review with the business whether things are actually relevant to bring into our data model. Remember, everything serves a purpose. With memory, we need to be careful. And performance could be, if this was a large data set, would be impacted. So we've got loyalty points. Someone obviously decided that was a good idea. We're going to build some insights with it, but we don't need it anymore. So the first thing we do in these types of situations when we're bringing in data is remove any redundancy, focus on performance. Dimensional tables might never be large, but these could still be tens of thousands of rows, and we need to treat everything very carefully. Again, we said that when we were shaping our data for our data model, we wanted to get rid of redundancy. Well, you can see in this building size column, we still want this, but we actually don't need, we've got square foot in the title, and then we've got a mixture of text there and an integer. So we actually just want to take the integer value. Well, there's a nice function that we can use for this. We can use text.select. We can specify our column as one of our parameters, and we can then basically state that we just want to take the numbers by supplying this list here. We'll just provide the numbers 0 to 9, and that's what we want to keep, basically the numbers. Now, you could have sort of delimited this or taken from a certain amount of characters, but let's say our source system was loose and we weren't confident people would enter this correctly freehand, so we wanted to be sure that we were taking the numbers. Now what we need to do, like we said before building this, take the data type, change it back to an integer format, a whole number, and there we are. We've got a bit more clear and strong data. Okay, so now to create our Power Query date table. we can just enter some data within Power Query, and we need to start with a start date. So as we started in this sample from the 1st of January 2022, that can be our start date. And now we need a custom column. So we can call this the end date. And what we can do is actually grab today's date, because we don't want to really hard code anything, because that will limit us in the future. It won't be scalable. We could forget. We're more prone to error. So we can take the local date time, which is just the date time as per our system, and that can form our end date, and that will grow naturally. It's dynamic, so that's great. Now what we need to do is we need to get a list of dates between that start and end date. So we can do this very easily again. This is a nice simple way to create a Power Query date table. And I won't go through every option you could add, because that will just waste a lot of our time, but I will certainly give you a good picture. So we can go ahead here, type in this small piece of M code, and we can get a list that gives us the relative dates from the start date and our dynamic end date. So we will go ahead and click OK. And now what we need to do is expand this list, and this will give us our date column. So we can go ahead and we can delete that start date and that end date column, and we can change that to a date data type. And we have the base of our Power Query date table already. So now you can go ahead and you can add whatever you like. I will show you a few examples, and you can research the rest if you like. But it's fairly straightforward. We just want to start using the GUI and the custom columns with a bit of M. We can populate our year, where we take the year part. Remember, the year isn't necessarily a date when it's on its own. That can just be a number. I haven't went through some of the date types and the naming, the applied steps, just for the sake of time. So again, we'll motor through this. We can add our month number for sorting and things like that. So we can get that from the dates as well. Date.month, fantastic. And then we can go ahead and we can start to change some data types if we've got the time, and we can get some more information in our custom column. So this time we may look for the month name, because we'll need that as well as the month number. So again, fairly intuitive. We've got the date.month name. You'll notice I've made a syntax error there. I should go back and correct that. So we've got date because I hit enter. I won't edit that out. That happens sometimes. I feel that M is sometimes quite hard to spot these things because it's quite bunched up naturally. So now we've got the month name. Again, we can change the type if we like to text. And again, we can add some more custom columns just to bulk out this Power Query date table. This will allow us to have that full body date dimension, perform some time intelligence, and really complete that initial and quite basic star schema that we've got. But we were missing that core element because we didn't really have a rigid system upstream. So there we go. We can take the short month name, just add one or two more columns for the sake of example, and then we can stop there. So one other thing that we might want to do is get the date of the end of the month. That may be helpful in some situations, maybe, financial situations. That would be particularly helpful where we need an end of month, maybe things like invoicing and so on. So we can just use date.end of month and the dates. There we go. And that should work fine. That will give us the relative end of the month. And lastly, we could just add something like the day of week, for example. And this will give us the numbered day of week. You could get the day of week name as well, just as easily. We could add a bit of text and an ampersand with a space, and we could start to show things like the day of the week is and the day of week. So there's a lot of possibilities here, but that's a nice simple way to complete our star schema for now and create a Power Query date table. Okay, so the last common transformation I wanted to show to set up our data model is to create a summary table. And you can see we've got a lot of information in our orders fact table. While I'm here, I do have a flag 0 or 1 for false or true, whether it's a phone order or an online order. I will change that. However, it may be the preference to leave it as a 0 or 1 flag, but just so that we can see, there we go. So in our orders table, we've got sales, and we really just want to see the sales by the customer key, the customer, and maybe we can look at it also by this roll up to the sales order view as well. We basically want to group it and show the sales by customer and sales order. So we can duplicate this query. But the great thing is we don't have to go through and delete any items, and we can actually aggregate this using the group by within the home ribbon. Now again, we could have done this upstream if we had a SQL database very simply with a query, but it's nice to know that we can also perform this logic here very simply if we have more fragmented and sort of unreliable data sources. So we can go to group by. I would always just naturally move to advanced. It's actually probably more simple to understand. So we want to group by the customer key, the customer. That's where we want to group the values into. And we can create a new column just called customer sales. And the operation will be the sum, and we want the sum of sales. So basically, we're creating a column that's the sum of the sales, and we're grouping that by the customer key. So it'll just be the sum of sales by customer. Now, what's great about this is it's another way of leaning out our data model. Potentially, we have other fields or other fact tables where we don't need a certain amount of information. Maybe we want to merge a table and do this. But this actually allows us to change the grain or the level. It's not as granular, the data now. We've gone up a level and grouped it. So it's quite interesting to see how you can do that within Power Query and work with different levels of data. Again, we could then change the structure again slightly by taking the sales order number. So we want to show the sum of sales by customer, but also by that sales order number by customer. So again, we can sort ascending. We don't have to worry about these steps. We can rectify that. And then you can see for customer 1, we have the sales number that totals a certain amount of sales, customer 2, and so on. So it's a really powerful way to lean out your data model as well and get everything prepared into the right shape. All right, so we've covered some of those interesting Power Query cases that will allow us to take a sort of fragmented data model to prep our data, to shape it, to change it, to make a complete star schema and more. We could even sort of create some sort of snowflaking elements as well. But now we wanted to sort of close this out by looking at real world data modeling challenges that you're likely to face in a business scenario. And it's not always possible to fix these just with Power BI. There are options where you could use Power Query, but again, we need to think about the best possible solution. And again, I've got one of these flows to highlight what I mean. So we're going to look at 2 examples, the first of which will be killing bad or poor quality data at source, and the second will be what slowly changing dimensions are, how they can be problematic, and ways that we could potentially get around these and make them work for us. So challenge 1 that you're likely to face, that plagues sort of most people at some point, would be poor data making its way through to your data model, or at least to sort of the ETL stages before your data model. And the best way around that is to actually kill the data quality issues at source. And again, by source, I mean in the source system. So there will likely be a case where people like to build things in a development environment where they're quite loose and fast and meet an operational need. However, this agile approach, as far as we're concerned as data experts, is not the best, because we like to have constraints. We like to be able to regulate and tighten up our data quality. And that's very hard to do if people have a lot of freedom when inputting data and so on. So like the text says here, you can largely attribute data quality issues to poor control within the source system, or poor control somewhere along the line with software developers or even the data team. Because at the end of the day, with all of these things, we need to have some sort of manual control, documentation, rules as to how we're going to sort of maintain these things. So like we said, the source app before could be a proprietary app, basically the company's own app, and there's a bit too much flexibility when users input the data, then we're going ahead and collecting that data in some way. So there would be ways to clean this in staging or Power Query, which is absolutely fine. If we needed to do that, we could. It's better than letting poor data slip all the way through and potentially sacrifice the credibility or quality of our end product, which is why I like to differentiate with that X, the difference between the sort of IT function with the software development and the data function with that expertise. My first inclination would always be, if we notice data quality issues coming through, rather than try and take them on and actually make them our responsibility, they need to be fixed at source. Now, there's always a conversation, hills you may not want to die on, and at the end of the day, it may come down your path, but you really want to make sure that this is handled at source wherever possible. The other thing is, if you were going to sort of start cleaning things in Power Query, there's a chance that you're going to lose traceability or visibility with some elements as they change, as they're cleaned, and you may not want to do that, especially when you're trying to highlight poor data quality. So again, if we even extend Roche's maximum of data transformation here, where it should be transformed as far upstream as possible, really that extends right the way up to the source app, especially if that's where the issue is originating. So I would recommend, instead of going through some of the Power Query steps we've shown and a lot of the other standard transformations, try and kill this at source and push that responsibility backwards. It could save you a lot of hassle. Now, there's another common issue that we'd want to regularly track, which would be slowly changing dimensions. So by that we mean a slowly changing dimension is a dimension which is relatively static, something like your customer information, but it can change unpredictably, and we would need to regulate sort of constraints and so on, and a process for when that happens. So it could be dimensions such as products, customers, locations, basically your dimensions. So as you can see here, this is a good image from SQL Shack. So we have varying levels, and really 0, 1, 2, 3, 4, and 6 would be some of the most common. So we have options. There's potential that you just really don't want to track anything and you can just overwrite them, or you can ignore changes and audit them. Type 2 and type 3 would be very common. So we would want to add the history as a new row or as a new column. Otherwise, a new dimension can be added, or we can combine the type 2 and 3, where we add a new row and a new column to reflect changes. Let's say when customer data changes, details for a customer could change. We could have new customers overwriting old ones. We could have companies consumed by other ones, and we need the data changes. And then you might want to compare insights with the historic data from the company, and with that dimension that changed. So like we said, what happens when customer data requires updates, and when things change, how are we going to track that? Well, it's something that's not really, there is an option to use SQL temporal tables and connect this through Power Query, but this is really something that makes sense to enable as far upstream as possible. With SQL, We have options to do this. This has been a very common practice. Even your technology like Azure Data Factory, if we're building pipelines to transport data, we can do it there. But again, this is almost another argument to have a really rigid structure as far upstream as possible. We could handle this in Power Query, but that would be as far downstream as we would want to go. A lot of these actions, like slowly changing dimensions, we want to tackle further up the stream. And if you don't tackle this, it can be a real problem with your dimensional data model and maintaining referential integrity. So that quality of data and the relationship could be damaged if we don't track things like slowly changing dimensions. So it's important to keep on top of it. Not just in data modeling, but one of the largest challenges you will face as part of a data team is documentation. And in this case, documenting data models. The reason that this is difficult is because it's one of the aspects of the job where it requires a lot of manual upkeep, maintenance, and discipline. So you'll often find documentation that either isn't upkept or never really started. But the value of documenting your data models is absolutely astounding for a few reasons. Obviously, you can share this with members of the wider business that maybe aren't so data literate, but they've got it in a nice universal format. It also means that you have a clear guidance when things change, any potential issues, and traceability of your data as it moves from the source into your data model. So it's incredibly crucial. It also gives you can build something like this, or you can use ER diagram tools online like Creately, which is very popular. You can choose to potentially use Azure DevOps Wiki. You can use GitHub repositories, or maybe even just Word documents if that's what works for you. The real point is that you collaborate well and you're sort of standardized in your practice and you agree on a method that works. Now, as you can see here, we can even get into stages, say if you were to build this in another data warehouse or even in Power Query, where you can start to reference relationships and keys. And it's just incredibly valuable to understand how your data model operates. As I say, it just takes a bit of determination and discipline to actually upkeep this, but it'll be more than worth it. But it's certainly a challenge. Also, by having a view of dependencies that certain tables have, how they relate to each other, when you actually go to, if you ever need to debug or if you want to improve performance, you've got a very easy manual and go-to to enable you to power up and improve your data models. Now, for some, simply providing the model layout, maybe a snip of that as you see it, may be enough, potentially with the view, with the relationships. Again, if you're going to do that, you've just got to be pretty dedicated in maintaining anything that changes. And you also need to realize that that's probably only going to work with people who are familiar with a data modeling tool. So if you're drifting more towards self-service BI, you might want to look at a more thorough document pack. That way, if someone like a business analyst came in who didn't have quite as much experience, you could just hand over that document pack and it gives them a really good reference to get started. So just in closing, obviously want to say thank you for listening to my presentation. I do find it hard to gauge. Obviously, you can't gauge where people are going to be at technically. So it's really valuable for me to be able to provide some insight on some of the issues I've faced and some of the issues you'll likely face when data modeling in real life or professionally. I think it comes down to a few key components. First of all, you need to understand the business and what they want and what they need, and really what basically the quality of the output of their data allows you to do. From there, you can go in and look at things like transforming data as far upstream as possible, the relevant grain you need to get the data in, and then you can decide on things like fact tables and dimensions. From there, you can work into your data prep, and then you can try and iteratively improve things. As long as you remember standardization, collaboration, you're going to be pretty well served by that. And as always, remember to documentation is key, and where possible, look at things like good data warehousing, rigidity, good constraints, and control over your source data. So you can follow me on some of my socials. Really, it's Matador Software where you can find me, and I'll be most active on YouTube and LinkedIn. So thank you once more, and I welcome any questions. I will do my best to answer them.